9/4 minus 9/2 plus 10. So the least common denominator is 4. 9 minus 18 and plus 40. So this is 12, this is 31. So you have to write natural log of 31/4 for the absolute maximum, not 2.0477. So it has to be entered as natural log of 31/4. And for the absolute max, f of 1 will be natural log of 1 plus 3 plus 10, 14. So please enter natural log of 31/4 for the absolute minimum. Natural log parentheses 31/4. And for absolute maximum, please enter natural log 14.
Yes.
It doesn't want 2 points. If it doesn't say any approximations, you have to enter it as the exact.
Okay. Yes, it is good now.
Perfect. Good. Next question. I'm just unplugging my computer. Next question. So that was 4, 5. Yes, 4, 5, 6. Yes. Any other topic? Anything? Chapters 2, 3, 4, and 5. I'm happy I got a full bottle. Small pleasures. Good. I'm ready for the next question. Please. Anything. Do you want us to go again to those lists of topics, or you have something for me?
Could we do one of the 3.7?
Yes.
So
applications of differentiation with the particle back and forth, and yes.
Yeah.
Speeding up and slowing down.
Yeah.
Good.
Okay. So the height in meters of a projectile shot vertically upward from a point 3 meters above the ground with an initial velocity of 25.5 meters per second is h equals 3 plus 25.5 t minus 4.9 t squared after t seconds.
Yes.
Find the initial velocity after two. This has like 5 different parts, but the first part is find the initial velocity in meters per second after 2 seconds and after 4 seconds.
So age of 2 and age of 4. Good. Part B.
Is when does the projectile reach its maximum height to 2 decimal places?
So that's when.
Yes.
And then the actual maximum.
Yep. Again, 2 decimal places.
Good.
Everything's 2 decimal places.
And
and then when does it hit the ground, and with what velocity does it hit the ground?
Good. Excellent. So first of all, I enter the function in the calculator. That's what lazy people do. I'm kidding. I like to say that, but we are using the technology. So 3 plus 2.25.5 t minus 4.9. That's g over 2, gravitational acceleration. 9.8 divided by 2. 4.9 t squared. So then I go to second and table, and I plug in 2 and 4. So 34.4. And is it in feet? Is age in feet? And 26.6?
Meters.
Oh, meters. Awesome.
But isn't it asking? It's asking for v, and we're given 8.
Oh, so they want the velocity or the
Yeah, they
or the
want
height?
v of 2 and v of 4.
Oh, sorry,
We're
sorry,
given
sorry.
8
Okay, sorry, sorry. In that case, we have to find the velocity. So v of t equals 25.5 minus 9.8 t. And then v of 2 and v of 4. Perfect. In y equals, I will put a new function in, it's 25.5. And then plus, I'm sorry, minus 9.8t. Good. So it's already done because we already put it in. 5.9, and this is meters per second, it's velocity, and negative 13.7 meters per second. Perfect. Okay, what am I doing here? Stop sharing. Okay, good. So then they're asking us when is the maximum attained and what is the actual maximum? Well, in order to find the maximum, we find the velocity. We find the derivative. And we set the derivative equal to 0. So 25.5 minus 9.8t is 0. That's when the maximum will exist, but I have to study the sign. I have to prove this. So I move this to the other side, this term to the other side, and I get 25.5 divided by 9.8, whatever that is. Oops, I didn't mean that. So 25.5 divided by 9.8. I got 2.6 approximately. They said 2 decimal digits. 2.60, and this is in seconds. Okay, I need to show that this is the maximum. So I have t, 0 and 2.6, and v of t, and this is 0. V of t at 0 is positive and is negative. So indeed, this will give us the maximum distance. What is the maximum distance or height? Is age of 2.6. And since I have the function in the graphing calculator, and the function is y1, I just want to plug in, I'm already there. I want to plug in 2.6. So it's 36.18. 36.18 in meters. So again, we determined that the maximum is obtained, maximum height of the projectile is obtained 2.6 seconds after we shut it up in the air. And what is the maximum height? Well, 36.18. The last question here is asking us, when does it hit the ground? And when I have the time, I will plug it in here to find the velocity at that moment. So how do I determine when it hits the ground? How do we determine when it hits the ground? So that's the last part. What does it mean it hits the ground?
The height is 0.
Exactly. And you don't have to solve this with the quadratic formula anymore. You are allowed to use the graphing calculator with the polynomial feature because it's a polynomial. Oh, sorry. So apps 9, polynomial root finder, degree 2. I have to get 2 solutions because it's degree 2. The first, be very careful how you enter this. The first coefficient is negative 4.9. The second coefficient is 25.5. and the free term is 3. And then you hit enter, and you get the solutions. Time cannot be negative. So the only one is t equals 5.32 seconds. Now they're asking us to find the velocity at 5.32. I already have the velocity entered. I already have the velocity entered. All I have to do is second and table, and I want to enter 5.32. And I read the velocity, not the distance, which is negative 26.64. So V of 5.32 is negative 26.64 in meters per second. Always remember, there is no negative speed. This is the direction. So in other words, the projectile does this. It's a quadratic function. So the velocity going up till the maximum will be positive, and afterwards it will be negative, because it's the slope, positive slope, slope, negative slope. It just shows that the rate of change is negative. How is this, Amanda? Everything okay?
Yes, just waiting. It's spinning. Waiting for it to load. Yep.
Yeah.
Okay.
That spinning is annoying sometimes.
Mhm.
Good. Other questions? Anything else that you would like to go back to? Maybe limits, maybe L'Hopital's rule, maybe integrals, approximations, Riemann sum.
What about some limits at infinity?
Yes? I hope you feel that you learned a lot in this class. A lot of topics, a lot of applications. Aaron, you're very quiet tonight. Okay, the next topic.
Okay.
Anything?
So it's from 2-6.
Yes?
And it's find the limit. The limit as x approaches 0.
Oh.
Or sorry, x approaches infinity. I'm sorry.
Oh, no worries.
Put my glasses back on. Okay. What is it? Okay. The square root of 4x squared plus x. And
Yes.
then minus 2x.
Good. So this is a typical situation for rationalizing. As long as this is an indeterminate case. See, this piece approaches infinity. But this piece, negative 2 times infinity, is negative infinity. But this is a problem. This is an indeterminate case. In other words, no clue. In other words, it can be 1500. We don't know. So in this situation, you cannot apply L'Hopital's rule. So we learned this way before L'Hopital's rule, and we have to rationalize with plus. The square root plus 2x and the square root plus 2x. So 4x squared plus x, 4x squared plus x. So this is a typical situation. for rationalizing. So when I rationalize, I have a minus b times a plus b. The denominator stays, but I have to factor out x squared inside. So I have 4 plus 1 over x. And I have plus 2x. When I multiply the tops, remember a minus b times a plus b, and that's 4x squared plus x minus 4x squared. So a minus b times a plus b is a squared minus b squared. Are we okay so far?
Yeah.
Now, luckily, these two go away. But next step is I have to take the square root. Do not forget the limit operator. We have not applied it yet. So you cannot drop it. So the top is x. But here I have to take the square root from x squared. It's a product now. And it depends on this. If this approaches positive infinity, then I have x. If this approaches negative infinity, then I have negative x. And the square root of 4 plus 1 over x plus 2x. In the next step, I have to factor out x. And when I factor out x, it will go away with that. And then I can apply the limit. So limit as x approaches infinity, x over, x outside, the square root of 4 plus 1 over x and plus 2. That was the whole idea, to get rid of these x's, one from the top, one from the bottom. And now we are dropping the limit operator because we are finding the final answer. In other words, the limit. What is the limit? Where is the top going and where is the denominator going?
The top is just 1.
Of course.
And then over infinity, which would be 0, right?
1 over infinity is 0.
Hello? Okay. Sorry, it froze for a second. The square root of 4, that's 2 plus 2 is 4.
That's it. Because remember, the limit as x approaches infinity of 1 over x, this is 0. Remember, 1 over infinity. $1 divvied up to everybody on the planet. You're not going to get much.